Alright, good morning everyone. My name is Lexi and I will be presenting on my project, the Custom Smart Mirror. So a lot of this is actually driven by the smart home craze that's been going around for the past couple years. Everybody wants to integrate their home to keep, simplicity in their lives. So what I wanted to do was implement a smart mirror. You see them a lot in beauty bloggers and things like that. That's not really my thing. I wanted to keep it more simple to the everyday user. The display that goes behind the two-way glass is very slim. All the software is run off of Raspberry Pi, and so when it's off it looks like a standard mirror, but whenever it turns on, it displays all of these widgets that you can install and customize. The three that I've actually chose to demo today is the current weather of Dallas, of course that's where we are, the current track that I have playing on Spotify, and the top headliners from different news broadcasters. The only thing I have turned on is that they're in English. So the first architecture option that I chose for this project was Publish Subscribe. The main components to it are the main display, of course, that's the subscriber, and every publisher is any API that I have as a widget. So in this case I have Spotify, Open Weather, and the news broadcasters. In between those I have a couple proxies just to handle all the information to getting the web services to display onto the subscriber. So of course I have different procedure calls that go to the event handler, which is what actually looks for events to display onto the main display, and then different connectors to talk to the APIs. This is my class diagram for the Publish Subscribe. As you can see, the first bit of it is the startup screen. That's where all of the tk-enter, which is what I chose for Python, displays all of the different information, formats everything to your screen. You can set it whether it's vertical, horizontal, all those great things. The event feeler is my event handler for this project. It's what actually feels out to see if any of the widgets have any new information to display. The three main widgets that I have are the news display, the Spotify display, and the weather display. All of these inherit from tk-frame, that way they can display properly onto the screen, and they each have their own text file, or in one case actually a cache file, to authenticate the user so that I can use those specific APIs. This is the component connectors to the class. Most of them are pretty self-explanatory. So if it's the publisher Spotify component, then it will be associated to the Spotify API in the Spotify display Python file, so on and so forth. Most of the connectors are just API calls that go back to whatever API I'm using their server so that it can retrieve data and display it onto the main display. So the second architecture option, very similar to the first, is the event-based. The main difference between the two was how the user would be interacting with the system. In the first one, actually, there is no interaction that the user can do other than it just displaying the main events that you want to see. In this case, the user would be able to interact with the display so that it could, say, skip a song or expand on a headline and be able to read the news from their mirror. So the main bit of this is the event bus that would handle all of the push and pulls to events. The same three widgets are there. The connectors would still be the same, except for the main display I would have to use some sort of voice assistant, since I think it would be kind of a hassle for someone who's standing in front of a mirror to just have a keyboard in front of them typing in all of these things. So using a voice assistant, such as Google's Assistant, would have to be implemented into the main display. The event-based class diagram becomes a little bit more difficult than the Publish Subscribe, as everything would have to be able to catch and throw all of their own events. The event feeler would be a lot more robust, and of course the Google Assistant handler would have to be implemented. So again, here is the component connector class connection mapping. Most of it, again, is very self-explanatory. All the connectors would just be calling over to their APIs or would be going from the handler to the main event bus. So in comparison of these architecture styles, for the publish subscribe we can first start off with. It is less expensive hardware-wise. You know, you just need a very basic display. You don't need any sort of microphones or anything like that. The ease of adding additional widgets in the future becomes much easier, so that way you don't have to worry about any specific API having some sort of difficult hardware dependencies that might have to be reworked on the user's end. It can handle a very large amount of subscribers, so if you want to add a ton of widgets all over your display, that would be completely customizable. The only downside to this is that, again, you cannot interact with these widgets. It would be solely display. For the event-based, it'd still be able to hold a large library of widgets that could grow increasingly complex if they were to interact with each other. The user would be able to interact with each widget, so it would be a lot more dynamic, and there would be a lot more on the back end to handle each individual call. The main downside to this, however, is that it is more expensive hardware-wise, as you probably would need some sort of touch display so that it can register what buttons you're clicking. You would need a microphone and a speaker so you could hear the response of the Google Assistant API. So again, my rationale behind choosing a pub sub mostly was the hardware restrictions. I will say my background is in electrical engineering, which is why I chose this sort of project. I wanted something that could mix in my more unique background with this software project. It's a fairly simple system, so that way everyday user could use it. All it would need to do is display high priority information, and again, the ease of adding new display widgets in the future is very, very simplistic. So this is just a very quick snapshot of what the main display looks like, as well as me compiling it, but I'll go ahead and show it to you. So here for the demo, I just have a boot up file for it to start up the display, and as you can see right now it is in the horizontal positioning, so it is a little bit retrofitted just for this demo. Usually it's vertical and fitted to whatever display you have it on. I was testing it on my TV because I don't actually have an external monitor for it to be tested on. So you can see that there are three main widgets on the main display. The first one I'll go over is the weather. You can change the location of where you want it. I have it in Celsius too. You can put that in Fahrenheit, however customization you want it to be. Down at the bottom are two of the major headlines that I go on. I find they change about every 20 to 30 minutes, but you can scroll through and change settings to it so you can get different languages. You can select different topics that you want to see. You can go into different news broadcasters, so if you only want like NBC or BBC, anything like that, you can have those specifics. In the top right corner is the Spotify. Right now it says no music playing, but if I were to open up my Spotify app, and I'll just move this so you can kind of see, and start playing. You can kind of hear the music. It updates pretty quickly depending on how good your internet is. You can scroll through all of your songs and it will update it pretty quickly. So this is kind of retrofitted more for the desktop. I did get it working on the Raspberry Pi before I found that my microphone had broke, and so another main function that I was able to sort of implement, but not for this demo, is the Google Assistant. As you can see, I'll just do like a, what time is it?
It's 9:55.
And so she has pretty good response time, but she has very limited responses that she can do because Google doesn't have a lot of customization to things outside of their product line, and I think that was my main fault in doing this with the Raspberry Pi. But this concludes my demo. Thank you for watching.